This last clue requires that you use everybody's favorite, the unit circle. So remember when looking at your unit circle, you start with 0, and as you travel counterclockwise around the unit circle, hit pi over 2, pi, 3 pi over 2, and 2 pi. Or in degrees, you have 0 degrees, 90, 180, 270, and 360. So now, if you have a value that's bigger than 2 pi or bigger than 360, that means you've just gone around more than once. So, for example, if you had 17 pi over 3 and you needed to know which quadrant that was in, you're going to take 17 pi over 3, pi over 3, and you're going to subtract 2 pi, because that would be a full revolution all the way around your circle. In order to subtract 2 pi, you need these to have common denominators. So I need there to be a 3 here, which means I need to multiply by 3 in my numerator, because whatever I do to my denominator, I have to do to my numerator, which gives me a new problem of 17 pi over 3 minus 6 pi over 3. And when I do 17 minus 6, I get 11 pi over 3, which still isn't on my unit circle, so I'm going to subtract another 6 pi over 3, and I'm going to keep doing this until I get something that's actually on my unit circle. And 5 pi over 3 is on my unit circle, so this allows me to tell what quadrant it's in. When I look at my unit circle, 5 pi over 3 is in the 4th quadrant. It's right here. So my answer to this would be quadrant 4. If I have a negative, like negative pi over 6, and I want to know what quadrant that's in. Remember, negatives reflect over x-axis. So I find regular pi over 6, which is right here. And when I reflect it over the x-axis, that puts it here. So this one is also in quadrant 4. Also, you'll need to remember how to find cosine of an angle, sine of an angle. Remember, cosine is your x value and sine is your y value.